magnetism we are going to discuss. But already in electric charges and fields also we have the same topic, that is between two charges. In electrostatics we have between two charges. One charge is Q1, other charge is Q2, and they are separated by distance R in vacuum. In vacuum. Then what is the force formula here means? This is in electrostatics. F is proportional to directly per Coulomb. This is a electrostatic force between two charges. Is directly proportional to product of the charges and inversely proportional to square of the distance between the two charges. So this is the thing what we noticed in the chapter electrostatics, electric charges and fields. There we discussed about the Coulomb's inverse square law between two charges. Here F is proportional to, we can write now, Q1 Q2 by R square. Directly we can write F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the formula what we can observe. Force between two charges. Force between two charges. Now similarly here in magnetism we are discussing that there are two poles here. One pole is M1, other pole is M2. Two poles are there separated by some distance. Separated by some distance. So now the distance separation here is R. Generally, monopoles does not exist in nature. Monopoles does not exist in nature, beta. We are considering and comparing with the topic. But actually, frankly speaking, monopoles does not exist. That is only South Pole or only North Pole does not exist at all. Magnet means definitely one is south, other one not. But here we are taking one single pole, either south pole or north pole, like that. Generally, in any substance, two poles will be there. Magnetic substance means south pole, north pole, south pole, but only north pole or only south pole does not exist. Here, small m1, m2 are pole strengths. There are two pole strengths, m1 and m2. These are, so the poles are separated by distance r. The poles are separated by distance r. Then these are also we are discussing the same topic in vacuum. Here also we are discussing the topic in vacuum here. So in vacuum, what will happen here, beta? The again force between these two things is directly proportional to product of pole strength and inversely proportional to square of the distance between them. I can again combine these two and write m1 m2 by r square. F is equal to, I can write mu naught by 4 pi m1 m2 by r square. M1 m2 by r square. This is the magnetic force between the two poles. So the force of attraction or repulsion, what is this F? F is force of attraction or repulsion between two magnetic poles. Between two magnetic poles. That is directly proportional to product of the poles. Inversely proportional to square of the distance. That is the reason we are calling it as Coulomb's inverse square law. This Coulomb's inverse square law. This is for the two charges separation by some distance. Here this is for two poles separated by some distance. This is also in between that is between two charges what is present vacuum. Between two poles also we are discussing separated in vacuum. So in that regard, here we got constant as 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Here we are calling it as mu naught by 4 pi. Mu naught by 4 pi. I hope you are clear with these two things, beta. Here M1, M2 are pole strengths. M1, M2 are pole strengths. Q1, Q2 are charges. Q1, Q2 are charges. So I compare these two topics like that and I discussed. I hope you are clear with this one. Next, let us observe now. Again, let us compare if they are taken in medium. So the two charges Q1, Q2, they are separated in some medium, dielectric medium here. So the distance separation is R. The distance separation is R. And here the two poles M1, M2 are there. Again, they are also told that separated by distance of small r in a medium. So now we are taking the medium between the two poles here. Medium when we discussed how to handle, how to understand. So here the magnetic nature when we have to discuss of the medium here. So here what happened in the first case, the formula I can write as F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Q1 Q2 by R square. This is the formula here. Here I can write the formula as F is equal to mu by 4 pi M1 M2 by R square. Now the question arises, sir, in previous page, you told us as a mu naught here. You told us something like mu naught term you have taken. Okay, mu naught by 4 pi is proportionality constant you told. And this is some mu naught you told. What is this mu naught? Here you told 1 by 4 pi epsilon naught is proportionality constant. What is this epsilon naught? What is this mu naught is called as? What is epsilon naught is called as? Like that we can have the information. And here the question they can also ask like this here. Epsilon is what? Mu is what? Let us discuss those terms now. Mu naught. What is mu naught means? Mu naught is nothing but here epsilon naught. Here we have discussed epsilon naught. Epsilon naught is nothing but permittivity of free space, and epsilon is called as permittivity of medium. Epsilon is called as permittivity of medium. This epsilon naught value is fixed beta. Epsilon naught value means we can take it as 8.85 into 10 power minus 12 Coulomb square by Newton meter square. Coulomb square by Newton meter square. Coulomb square by Newton. Coulomb square by Newton meter square. I hope you are clear till here. This is about epsilon and epsilon naught. Epsilon naught is for permittivity of free space or vacuum. This one, what I told, just observe carefully. Permittivity of free space or vacuum. That is when they are separate in vacuum, you have to use epsilon. No, when separate in some medium, you have to take epsilon. This value is not constant. This value will be going on changing from medium to medium. But epsilon naught value is same. Epsilon naught value will not change anything here. So it is a fixed value we have. So here the property of medium which allows the magnetic field lines to pass through it is called permeability. Mu is called permeability. The property of medium which allows the electric lines of force to pass through it is called permittivity. This is the permittivity and a permittivity of free space or vacuum. Here mu is called permeability. Mu is called permeability. Mu naught. Let us take first mu naught. Permeability of free space or vacuum. Permeability of free space or vacuum. Mu is called permeability of medium. Permeability of medium. And here, what is mu naught? What is mu naught? Mu naught value is, I can write it as 4 pi into 10 power minus 7. 4 pi into 10 power minus 7 Newton. Here, actually, how to write the units observed? This is the mu value. Suppose mu value I want. So, mu means here, what is this one? F is Newton. Here, ampere meter. This is a meter square cancel. So, R is what beta? Distance unit meter square. Pole strength units ampere meter into ampere meter means ampere square meter square. So meter square cancel. So what we can write here? Newton per ampere square. Newton per ampere square. Like that, I can write the units Newton per ampere square. So here, actually, whenever we are writing one units better, remember here you have to take care about the dimensional formula also. That means the dimensions, how they are for the charges and everything, and we have to apply the units. Okay, those things again we'll discuss in detail about units and dimensions chapter, about how to handle the units and dimensional formula and everything. Now I hope you are clear till here. Now coming to here, next topic, what we are going to discuss is about the force we discussed, and we have to know one more term here in the both the cases. There is a term called epsilon r. Here the term called mu r. Epsilon r is the ratio of permittivity of medium to permittivity of free space or vacuum. Mu r is the ratio of permittivity of medium to permittivity of vacuum. Permeability of medium to permeability of vacuum. Like that, we have the two things here. So epsilon r is called relative permittivity. Relative permittivity. Here, relative permittivity we call it as relative permittivity. And this mu r is called as, what is mu r? Mu r is called relative permeability. Relative permeability. So these are the terms to be known. So instead of giving directly epsilon value, to make it shortcut, they are just giving epsilon r into epsilon r. So directly they are not giving mu value, they will give epsilon r value. If you know epsilon r, multiply with epsilon naught, you will get epsilon. They will give the mu r values in shortcut. Small values will be there for mu r and epsilon r. If you multiply with the mu naught, you will get that medium permeability or medium permittivity. Like that, they are taking these terms epsilon r and mu r. So this is the information when we are comparing the two things better. When we are comparing the magnetic force and electrostatic force, these are the main points to be noted when you are comparing. So here mu r, whenever you are taking free space they told, free space or vacuum. Free space means we assume it as vacuum. Free space means what is mu r value? 1. Epsilon r value? 1. So mu r or epsilon r values are taken as 1 in free space. In free space. So I hope you are clear till here. So this is the information, basic information about Coulombs force. Coulombs force between the two charges as well as Coulombs force between two poles. Basic information. This is the basic information related to the two topics. I hope you are clear with these ideas. So we discussed actually magnetic force as well as electrostatic force. Magnetic force as well as electrostatic force, both the differences at a time we discussed in this topic.